Hello and welcome to my YouTube channel. Today in this tutorial, let's talk about prime numbers. A prime number is a natural number greater than 1 that has no positive divisor other than 1 and itself. Natural numbers are the positive integers used for counting 1, 2, 3, 4, 5, 6 like that. And here positive divisor of an integer are the positive integers that divide it evenly without leaving a remainder. Given number is a prime number if it is a natural number greater than 1 and has no positive divisor other than 1 and itself. For example, 2 is a prime number because it is a natural number greater than 1 and has no positive divisors other than 1 and 2. 3 is also a prime number. 5 is also a prime number. 7 is also a prime number. But 4 is not a prime number because 4 has a positive divisor other than 1 and 4, that is 2. 4 is a natural number, it is greater than 1 but has a positive divisor other than 1 and 4, so it is not a prime number. 10 is also not a prime number because 10 has other positive divisors other than 1 and itself. Next, let's see how to find all the positive divisors of the given number. To find all the positive divisor of the given number, what we need to do is we need to start from 1 and we need to divide that number from 1 to till that number. And we need to check for the remainder. If we get 0 as the remainder, then that number is the positive divisor of the given number. For example, let's take 15. Our number is 15. So to find all the positive divisor of 15, we need to start from 1. Let's divide 15 by 1 and we need to check for the remainder. If remainder is 0, then 1 is the positive divisor of 15. Then 15 divided by 2, check for the remainder. Remainder is not 0, then it is not the positive divisor of 15. We need to do this till 15. Here we can see 1, 3, 5 are the positive divisors of the 15. This is to check the positive divisor of a given number. Then how to check whether the given number is prime or not? To check whether a number is prime or not, we need to divide the given number from 2 because prime number can have two positive divisor, 1 and itself. So start from 2, divide that number by 2, check for the remainder. If the remainder is 0, then that means 2 is also the positive divisor of that number. So it is not a prime number. If remainder is not 0, then divide the number by 3, check for the remainder. And if remainder is 0, then 3 is the positive divisor of the given number. Stop. Given number is not a prime number. If remainder is not 0, then go to the next number. So we need to do this till previous number of the given number. For example, if the given number is 15, if we want to check whether 15 is prime or not, we need to start from 2. We need to divide the given number by 2. We need to check for the remainder. Next, divide the number by 3, check for the remainder, like that. Here 15 is not a prime number because it is divisible by 3. It is completely divisible by 3. So 3 is the positive divisor of 15. So it is not a prime number. Let's take another example, 11. So given number is 11. First, divide the number by 2, check for the remainder. So for that we can use modulo operation like this. Remainder is not 0. So take the next number, divide the given number by 3, no, then by 4, no, by 5, 6, 7, 8, 9, 10. No need to divide the number by 11 because prime number can have only two divisors, 1 and itself. So no need to check for 1 and 11. So we need to search for the other positive divisors in between 1 and 11. So there is no positive divisor here. Between 1 and 11, 11 is a prime number. Now my next question is it necessary to divide the given number from 2 to previous number of that number? For example, what if the given number is 101? Whether I need to divide the number from 2 to 100? Actually no, there is a shorter and faster method to check whether the given number is prime or not. No need to divide the number from 2 to till the previous number of the given number. First method is very simple, straightforward method, but it is very lengthy and time consuming, especially for large numbers. To reduce this, we can divide the number only up to its square root, because if the number has any factor greater than the square root, the smaller factor would already be found. This is the second method, actually the shorter method. What we need to do is we need to divide the number starting from 2 to till square root of that number. For example, 101 is our number. First, let's divide the number by 2. Check for the remainder. Then 3, then 4, then 5. So, we need to do this till square root of 101. So, we won't get the whole number here. So, just round it off. We need to check till square root of that number. No need to check till the previous number of that number. This is the first method and this is the second method. Second method is shorter and faster. Let's take another example. Let's take 36 as a number. Here you can see using first method and second method. Second method is more helpful when number is a larger number and it is not a prime number. So next, let's talk about the logic behind the second method. Why checking divisibility only up to the square root of the given number works. Let's take a number and let's assume that it is not a prime number. So if number is not a prime number, then we can write it like this: a multiply b. A and b are the factors. For example, if number is 36, then I can write it as 2 multiply 18. Now here, both a and b can't be greater than square root of number. If both a and b are greater than square root of n, then we'll get the product which is greater than the number, right? In any factorization of the number, at least one of the factor must be less than or equal to the square root of the number. And if we can't find any factor less than or equal to the square root of the number, then that number must be a prime number. This is the logic behind the second method. If no number divides n from 2 to square root of n, then no number greater than square root of n can divide it either. Just for an example, if I take number as 36, so you can write the factor pairs like this, right? And after 6, we can see it will repeat in the reverse order. Factors repeat in the reverse. So checking beyond 6, that is square root of that number, is actually not necessary. Let's take another example. If I take number as 29, which is a prime number, so check till 5. So no divisor found, so it is a prime number. Okay, so when we want to check whether a given number is prime number or not, what we can do is we can divide that number starting from 2 to till square root of that number. If we didn't find any positive divisor of that number in that range, then that number is a prime number. So this is about prime numbers. So that's it for now, guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.